Well, hello, have you been missing me? I hope you have, because I've been missing you. It's good to be back and talking to you while I am vacationing in the Bahamas. Are you happy that I played that song for you again? A mole is a unit, or have you heard, contains 6 times? Yes, I know you wanted me to play that song. Alright, so I'm going to try and make sense of what Mr. Khan in the video before me took quite a bit of explaining to do. Okay? So do me a favor. I want you to write down this first I can statement here. I want you to write down, I can explain how Avogadro's number is related to a mole of any substance. I know this can sound very confusing, talking about a mole in Avogadro, whatever's number. Here's what I want you to keep in mind. What Mr. Khan at that last video said at the very beginning is right. It's a number, all right? And think of it like this. You're comparing it to what a dozen means. If I said to you, we have a dozen apples, you would say a dozen is 12 of any substance. You know that you have 12 apples. You don't even have to think about it. Okay? The mole is a word like that. So having a mole of something, okay, it's not 12 of that substance. It's a much bigger number. Okay? And the reason why we need this is because atoms and molecules we're talking about, they're so small. There's so many of them in any given substance you can think about it. Last video he said there's 1 million of them in just the diameter of a hair. Okay, so the substances that are around us everywhere have a lot of atoms in it. Okay, and so we need to have a really big number for the mole here. And so it's as simple as this. Avogadro's number is a mole of any substance. Okay? That number is a mole. That's what a mole is. It's not 12. It's our 6 times 10 to the 23rd number, which is a lot of zeros. You know that. It's a huge number. I want you to actually not do 6.0 times 10 to the 23rd. We're going to be a little more specific. We're going to use the 6.02 times 10 to the 23rd numbers of anything. Okay. Apples, cars, marshmallows. Okay, that's more cars than we could ever possibly make. More marshmallows that we could ever possibly think of. Okay. So you're talking about numbers of usually atoms, ions, compounds, or molecules. These are the things we're going to be working with when we're talking about the term mole. 1 mole of anything is this many number of it. Right? So let's just pick an atom. He was really struggling through, I thought, that aluminum example. So let's take a look at that. Okay, write this down. Mr. Kessler will pause this if he needs to, but I'm going to move on. One mole. And here's the thing, let me tell you what this abbreviation for the mole is. It's going to save you a ton of time. Instead of writing M-O-L-E, you're going to write 1 M-O-L. And that just helps a lot. Okay, 1 mole of aluminum equals 6.02 times 10 to the 23rd atoms of aluminum. Let me do one more example right here, comparing this to a molecule. If you have 1 mole of water, it's the same number, 6.02 times 10 to the 23rd mole is that number. But water is composed, 3 atoms make up this molecule, so we say we have this many molecules. And you know what, one of my students a couple years ago was like, let's abbreviate molecules to cules. I love it. So that is 6.02 times 10 to the 23 cules. Not very scientific here, but I like it. So you'll see me do that quite a bit. Now, that is a mole and the number of something. Here's another thing that Mr. Kahn I thought was struggling a little bit to try to explain. How is that related to the mass of something? And it's so much easier than what he was trying to do there. It took him quite a while to get this. Do me a favor, write this next I can statement down, because that's what's going to head our notes. I can calculate the mass of a mole of A elements. Okay. I can calculate the mass of a mole of an element. All right, so do me a favor. This is it right here. Write down this definition, please. This word, molar mass. I'm always going to be saying, what's the molar mass? Okay, and so here's the definition. It's the mass of 1 mole of an element expressed in grams. Okay. Hurry up, write that down, because he's not going to pause it. No pausing. Hurry up, write it down. Hurry up, write it down. Hurry. Go. Okay. Now, it is so much easier than what Mr. Kahn was talking about there. Write this down next. Molar mass of an element is the atomic mass from the periodic table. You just change the unit. You don't need AMUs. We're not going to have AMUs there. To grams. Okay. So whatever our number on our periodic table, which I know you guys can't see, you should hopefully be looking at the periodic table I gave you as a worksheet here. Whatever that atomic mass is, that's how many grams are in 1 mole of that element. I'm going to say that one more time. Whatever that atomic mass is, that's how many grams are in 1 mole of that element. It's as simple as this. We know 1 mole of aluminum is this many atoms. One mole of aluminum, this many atoms, has a mass .0 grams. Okay. On your periodic table, it says 26.98 is the atomic mass. What I want us to do, unless I tell you otherwise, let's go to 1 decimal place when we're doing molar mass. So just round that 26.98 to 27.0. And how we'll write this usually is 1 mole Al equals 27.0 grams of Al. Not 27 grams of any substance or any other element. Has to be 27 grams of aluminum. That's how you have 1 mole. Now let's do a couple more examples. 1 mole of, I don't know, let's say beryllium, Be. Right? 9.0 grams of beryllium, because that is the atomic mass that you're going to see when you look at your periodic table for beryllium. And yeah, I double checked it twice just to make sure. 1 mole of magnesium equals 24.3 grams of magnesium. Okay. So molar mass. This is the mass of how much of each of these substances are in 1 mole. And remember what that means is there are 6.02 times 10 to the 23rd atoms for each one of those to equal this mass here. Okay, not too bad. All right, now I want to change this I can statement here, and we're going to erase the word element. I want you to write down compound or molecule. I can calculate the mass of a mole of a compound or molecule. And it's just this easy. A compound or molecule has a formula, okay? And the formula tells you how many atoms of each one are in that formula. You're just going to add up all the different atoms that are in the formula. You need the atomic mass of each one of those atoms, and you just add them all together. Okay? So let's do an example. I believe on the worksheet, my example was calcium chloride. Yes, calcium chloride. Okay, so 1 mole of CaCl2. Okay. So in this particular compound here, you have an atom of calcium for every 2 chlorines. So all you do is you're going to add up your mass of all 3 things there. 1 calcium, which is 40 something, 40.11. We'll just go 40.1 because I told you that's what you'd be able to do. Okay. Plus chlorine, one of them is 35.5 grams. And then we got 2 of them here. So you got to have 35.5 grams 2 times. Add all those up. 1 mole of CaCl2 equals 111.1 grams of CaCl2. So 111.1 grams of CaCl2 is 1 mole of CaCl2. For calculating molar mass of compounds or molecules, you just add each particular atom up in its formula. So let's just do one more example. Let's say water. Okay. So the atomic mass of hydrogen is 1. So you got 1 plus 1, because there's 2 of them in here, plus 16. And this is all 0.0, all these if you round them. And so it ends up, you use this quite a bit, I'm sure. The molar mass of water is 18 grams of H2O equals 1 mole of H2O. All right. Now you got this worksheet here to practice. I also, as a review, please tell me what kind of substance each one of these particular things are. Are they an atom? Are they a compound? Or are they a molecule? And you're also going to practice, how do we name those things? I know I'm asking a lot. I will see you later.